So today we're going to be graphing quadratics in factored form. And the idea is that factored form is going to give us the two zeros, the two factors, or the two roots of the equation. And this is going to be different than vertex form because the vertex is found directly between these two roots. And this is based off something called the zero product property. The zero product property says that if this is 0, I don't care what's over here because the whole thing is going to be 0. And likewise, if this factor equals 0, I don't care what's over here because 0 times whatever is still going to be 0. So that's what makes this special. And so I know that if I want my y value to be 0, I only need one or the other to be 0. So that's going to allow me to find what I call my root 1 and my root 2. My root 1 is simply x minus 1. If that equals 0, then it doesn't matter what's over here. So I add my 1 to both sides. I found my first root. So I'm going to plug in a nice point at x equals 1. For my root 2, I say, okay, so x minus 3 is equal to 0. Add 3 to both sides. I get x equals 3. Boom. And so now what I'm looking at is I know that my quadratic is either going to curve down through those points or up through those points. And it could be a really steep up and go very high, or it could just be a little up and be relatively flat. We don't know. So what we're going to need to do is we need to find where the vertex is, which we know is found directly between the two roots. So I'm going to ask myself, what's directly between 1 and 3? Well, 2. And so 2 is what we actually call our axis of symmetry. And that just means that what's on the left is a mirror image of what's on the right. So my axis of symmetry is x is equal to 2. So I just need to know where along this axis, my vertex is going to be somewhere. It might be through this part, it might be through farther down, it might be through somewhere up. So what I'm going to do is I'm going to plug x equals 2 into my equation to find where that graph is. And so I say, okay, to find the vertex, plug in f of 2. And that's going to equal minus 1, minus 3. I'm going to plug my 2 into both spots where there's an x. So 2 minus 1 is going to give me a 1. 2 minus 3 is negative 1. 1 times negative 1 is negative 1. So my vertex is at 2, negative 1. So 2, negative 1. Boom. So I have my graph. Now, we know that when we curve it through, you could graph some more points, but realistically speaking, we know the minimum height, we know the two zeros. The only thing is we could find is the y-intercept, and we'll find that out at a later date. So as long as you can graph the two zeros, the two roots, and the vertex, we're good on graphing quadratics in factored form. So let's try one more. We notice that this one has a negative sign out front. So will that mess up our answers? No. For root 1, I'm going to say x plus 1 is equal to 0. For root 2, x plus 3 is equal to 0. Because I know that if either one of them is 0, 0 times the other thing is going to be flat, which is going to give me some point along this line. So I have an x of negative 1, an x of negative 3. Oh, cool. So this is kind of a mirror image of what we just did. Negative 1, negative 3. And so we know that the vertex is going to be somewhere between these two on this thing called the axis of symmetry. We know it repeats on each side. And so my axis of symmetry is x is negative 2. So what's special about that is that if my vertex exists somewhere at x equals negative 2, I can just plug it in. So let's go ahead and let's do that. Let's find the vertex. So f of negative 2 equals negative plus 1 plus 3. So negative 2 plus 1 and negative 2 plus 3. So negative, it's negative 1, 1. Negative times a negative is going to be a positive 1 times positive 1. We get a vertex at negative 2, comma, 1. Oh, cool. So what we know is that the graph is going to curve up through that point and curve down back in this direction. And so that's a flipped version, and the big indicator is the fact that that negative sign, if we remember our transformations, means that the graph flips. So what I want you to do is I want you to pause the video. I want you to try number 5 and see how you do. Okay, let's give it a shot. I know my root 1 and my root 2. So if I have x minus 2 is 0 and x plus 2 is 0, that means x equals 2 and negative 2. So I have a point 2 and negative 2. Oh. So that must mean if my vertex is directly between them, it's somewhere along this line right there. So now my axis of symmetry is at x equals 0. I just got to plug that in, see what happens. So I'm going to do that. So if I plug in f of 0, and I like this because 0 is always easy to work with. 0 minus 2, 0 plus 2. Now that's going to be a negative 2 times a positive 2, which is going to be a negative 4. So now my coordinate for my vertex is at 0, negative 4. Right there. So what we have is we have a quadratic just like that. Perfect. So let's try something a little different. What happens if I don't have two complete factors? Well, it's a little deceiving because we do. I know I have one of my roots, my root 1, is going to be where x plus 4 is equal to 0. But what's going on with that? Well, I could look at it as what happens if I put that in parentheses. Well, there's my other root. So root 2 is just where negative x is equal to 0. Because if either one of these is equal to 0, the entire other thing is. Which means that if x equals negative 4, I could plug that in. Negative 4 plus 4 is 0. That obliterates everything. If x was 0, plug that in. Negative 0 is 0. 0 times whatever that is, I don't even care. 0 times that is 0. So those are my two roots, at 0 and at negative 4. Which means that my axis of symmetry is somewhere where x is negative 2 again. So we're going to go ahead and we're going to plug in f of negative 2. So it equals a negative 2 times negative 2 plus 4. And I know a negative 2 is going to give me a positive 2. Negative 2 plus 4 is going to give me a positive 2. Positive 2 and positive 2 is going to give me a positive 4. So now my vertex is going to be found at negative 2, comma, 4. Negative 2, 4. Oh, hey, So I notice again that if I have a negative leading out front there, I know that my quadratic is going to be upside down. Yeah. Should have a steadier hand. Cool. And so these last two are what happens if we have fractions. Now, realistically with this one, I designed it a little bit more difficult than it should be, but we're going to use it and we're going to get the point across. So what we know is we know our two roots. Root 1 is where 2x plus 3 is 0, and the other one is where 4x plus 3 is 0. I know if I subtract the 3, 2x is negative 3. Divide by 2, x is negative 3 halves. I know at negative 3 halves, I have a root. It's not quite at 2. It's kind of in between two values. For my other root, 4x is negative 3. X is negative 3 fourths. And so this one is right there. And now what a lot of people would be tempted to do is they'd say, hey, it's going to be 1, because 1 is between those two, right? Well, remember, this is basically a quarter away from negative 1, and that's a half away from negative 1. So it's not balanced. So what we're going to have to do is we're going to have to find what is directly between those 2 points. And we do that by finding the average. Let's go ahead and figure out what the average of these 2 points are. So to find the average, what we call x bar, is we take negative 3 halves and we add it to negative 3 fourths, and we divide it in half. So we know the fact that these need to have a common denominator, which means that I need to have negative 6 fourths minus 3 fourths, all divided by 2. So 6 fourths minus 3 fourths is negative 9 fourths, all divided by 2. So I'm going to keep, change, flip, negative 9 fourths times 1/2, which is going to give me a negative 9/8. So that is where my axis of symmetry lies. At this really awkward value of negative 9/8. It's not pretty, but it works. Now, somewhere along that line is going to be my vertex. So I'm going to plug that in and say, to find my vertex, I'm going to take f of negative 9/8 equals 2 plus 3, 4 plus 3. And we see that this is going to get a little dirty. That's okay. Negative 9/8, negative 9/8. So our first step is we're going to multiply this. I know that that's going to turn into an 18 divided by 8, which is going to reduce because 2 divided by 8 will reduce. That'll turn that into a 4. So that'll be a negative 9 fourths plus 3. 4 divided by 8 is going to be 1/2, so it's going to turn that into a 2. So negative 9 halves plus 3. I'll come up over here into this box to give me some room. I know that to add these two, I need them to be common. So that's going to be a negative 9 fourths plus, well, if I turn 3 into a fourth, that's going to be 12 fourths. And over here, if I turn 3 into a half, that's going to be negative 9 halves plus 6 halves. So getting these together, I have 3 fourths times negative 3 fourths, which is going to give me a negative 9/8. So my f of negative 9/8, negative 9/8. Well, that's an interesting vertex. Negative 9/8, negative 9/8. That's a very skinny vertex. like I said, the only thing that we probably could find after this is where the y-intercept is. That might be an important point. But as of right now, we're just focusing on graphing these 2 points and graphing the vertex to find that curve. We know this is a very skinny parabola. This new piece of information of finding the mean, finding that middle piece, is the only new part. So what I want you to do, last one isn't quite as dirty. Pause the video, see if you can solve it, unpause it when you're done. Okay. So if I find root 1 and root 2, root 1 is at 2x minus 3 is 0. This one is 2x plus 3 is 0. So I add 3 and divide by 2. Subtract 3 and divide by 2. Boop, boop. So I know I have, let's see, 3 halves, which is about 1.5, and negative 3 halves, which is negative 1.5. Well, I know those are on opposite sides of my origin line, or my y-axis. So my axis of symmetry is where x is equal to 0. But just in case, let's say it was an example like this. How do I find the mean or the average? Well, I know that my x bar is 3 halves plus a negative 3 halves, all divided by 2. And this is much simpler. We know that 3 halves minus 3 halves is going to be a 0 divided by 2, which is a 0. So that's an easy way to figure out this if it looks like it's going to be a little difficult to solve. So to find my vertex, I just plug it in. So f of 0, which we always like because zeros work really well. 2 times 0 minus 3 times 2 times 0 plus 3. 2 times 0 cancels out, so it's just going to be a negative 3 times positive 3, or negative 9. That was much easier. And so unfortunately I didn't draw this to scale, so I can't fit a negative 9 on here. So what I'm going to have to do is I'm going to have to go ahead, my x's have to be by 1s because I've already plotted those points, but I'm going to draw my y by 2s. That's going to allow me to stick 2, 4, 6, 8, 9. So what we get is we get a quadratic that looks like that. There we go.